All right, so for this next section, for the next video, we're going to pretend that we don't have a TI Inspire calculator because maybe a lot of you haven't been able to download that emulator yet or whatever. Or you're like me and you just don't have one laying around the house. So we're going to do it by hand, which is not that bad. It's a little bit more time consuming, but generally it's not really that bad. So what we need for the do is we need to base our conclusion around a critical t and a critical, or I'm sorry, and its associated p-value that we'll find in this section. So first we need to find the critical t. Now if you remember from your notes, the t is equal to, I don't know if you can see that very well, but I'll zoom it in here a little bit. The sampling mean minus the population mean over the sample standard deviation divided by the square root of n. And we have all of these things. They're in the problem. So our population mean is 94. That's the first thing given to us. The sample size is 32. The sample mean is 96.5. And the sample standard deviation is 6.3. And just for good measure, it says our alpha is 0.05. So alpha equals 0.05. There you go. So from here, it's just a little bit of algebra. So we'll plug in these values into this formula. So let's see, 96.5 minus 94 over 6.3 divided by square root of 32. Well, on the top, this is 2.5. On the bottom, 6.3 divided by square root of 32. I already did it. 6.3 divided by 32 to the power of 0.5. And there you go. So the denominator is 1.114. If I'm rounding, which I'm going to, you can't stop me. So then 2.5 divided by 1.114. You can't see that at all. There you go. There's your critical T. 2.24. Perfect. All right, so this next part is a bit of a trip. So what we have to do is we have to take this critical T and this N to our table, which you guys probably still have an electronic version of. I didn't feel like finding mine, so I just grabbed one of the textbooks. So what we're going to do is we're going to find the degrees of freedom, which, as we know, is based on our sample size. Remember, degrees of freedom is n minus 1, so in this case it's 31. So we got to find that row on our table. So I look over here on the left-hand side where I see degrees of freedom, and I scroll down until I see 31. 31's not there. It goes from 30 to 40. Yours might. Mine doesn't. So what I'm going to do, I'm going to have to round down to 30. And so I'm going to look in this row exclusively. I'm going to ignore every other row. Now what I need to do, since I do that, I got to find where 2.24 is in this table. Or in that row, rather, sorry. So I go over here, I scroll to the right, I get here 2.147. And then it jumps to 2.457. So I know that it's somewhere in between these two numbers. So from there, I'm going to look up and see, okay, well, what tail probability am I talking about? Oh, I'm between 0.02 and 0.01. So I'll say maybe 0.015. So my p-value, I'm going to assume is about 0.015. And there you go. You now have a critical T and a critical P. I'm sorry, not a critical P, a P value that you can base your conclusion on. And you didn't need the Inspire calculator. You did it all by hand. So great job. So with that information, we go to the do section and say our t-test, sample t-test with 31 degrees of freedom is a critical T equal to, what did we say, 2.24, and a p-value of 0.015. And there you go, all done. It is a good idea to write your work on your paper, but I didn't on mine because obviously I'm just typing, so you'd have no way of seeing that. But yeah, there you go. There's your do portion.